Alright, hi everyone, this is Nico, and this talk is going to be about understanding the entity component system architecture better. This tutorial is going to be practical, but it's also going to be about understanding the theory behind everything. So this little diagram we have here, where we show all the pieces, is going to be key to understanding all of the stuff we're going to see today. Essentially, the entity component system architecture is built of 3 building blocks: entities, components, and systems. And we'll see that these things make up everything in a Decentraland scene. We'll go one part at a time, but essentially the engine is the main root thing that orchestrates everything else. But entities are basically all of the things that are in your scenes. So everything in your scene that is visible or that emits a sound is gonna always be an entity. And entities have components, which are the things that give traits to these entities. So for example, if I have a 3D model in a scene, that will be an entity, and that same entity will have both a shape component that will tell us what shape to give it, and a transform component that will tell us what position, rotation, and scale to give that. Systems, on the other hand, are about making things happen. They are about creating actions in a scene. So entities and components are all about storing the state of something, and systems are about changing these things. Now, if you are familiar with an object-oriented architecture, you might find this a bit strange, because in that kind of way of thinking, we have objects that have both methods and state all stored inside the same object. In this scenario, instead, we have the systems as something that's external to the entities. That is what acts upon the entities. So methods are what would be equivalent to methods in an object-oriented architecture is something external. And that might be a bit abstract, but it pays off. This is a very common and standard kind of architecture to use in games in general. And we'll see that this allows us to scale things a lot better. It's also great for multiplayer scenarios, but it's also a lot more performant in many ways. And it also helps us construct complex combinations of behaviors that might work together to create something else, without them necessarily needing to interact directly with each other. So we'll go into more concrete examples of all of this, and if this sounds a bit too abstract at this point, just hold on for a minute and we'll try to make this a bit more concrete. So let's start by building an example. So I created an empty folder where all we have is nothing but an empty folder, and I'm gonna run DCL init so that we build the basic scaffolding of a scene. And what we'll build, by the way, is basically one of the examples that we have in the Decentraland Awesome repository, which, by the way, is a great resource to learn about the SDK, and is full of really good examples and things that you can copy in your own scenes. But we'll be building the example that is covered in this tutorial. That is also covered down here. It's the Hypno Wheels example. So if you want to follow along and do this while you're watching this as a video, maybe pausing every now and then, you might want to check out this example, and you can at least download the art assets that go into this so that you can replicate it in full. So for now, I'm just gonna literally copy the art assets into my folder manually. I'm gonna create a folder called models and a folder called images, and I'm just gonna copy and paste these files that I have from somewhere else. So in models, I'm gonna paste this theater.dlb, which is basically the 3D model that we'll use as the base for our scene. And in images, I'm gonna copy this material I have here, which is just a PNG image with this spiral texture that we'll apply somewhere else. So I'm gonna also have Visual Studio open, and here we are seeing the game.ts file for this scene that I just created. I'm gonna erase everything we have here and start from absolute scratch. So the obvious first step is to create an entity. So let's go with entity, and we're gonna add this entity to the engine. So this step is important because until you add the entity to the engine, you might create something that exists in memory, but it won't be rendered in the scene. So let's refer back to this model. We just created an entity and we added it to the engine. Now what we're going to do is create components and add those to the entity so that this entity really has something. So the entity really is just a container to add many components. So we're going to add this. We're going to add two things to this entity. We're going to give it a shape and we're going to give it a transform. And both of those things don't really make much sense on their own. They need each other to really like have a meaning and make sense in some way. So like if we have a position for something, that doesn't really translate into something appearing visibly in our scene until there's something to show in that position. And likewise, if we give something a shape but we don't give that a position, well, by default it's going to appear in the 0, 0 of the scene, but like that's rarely what we want, right? I mean, it's most likely going to be outside the bounds of the scene, so that's not good. So let's add two components to our entity. So we're going to go with base, add component, and we're going to first do a new GLTF shape so that we use our 3D model. And this takes one argument when we're creating it, which is the name, or the path rather, to the 3D model. So in this case, it's model/GLB. And we are going to add the second component, which is and this transform is going to have, for now, just a position, which is a vector 3, because it has 3 coordinates x, y, and z, as you can see here in the description. And these relate to the coordinates in the space in the scene. And since our scene is a single parcel scene, that means that our scene measures 16 meters by 16 meters. So the center of our scene is in 8, 0, 8. So 8 meters on the x-axis, 0 on the z, so on the y-axis, sorry. So it's near the ground, and 8 on the z-axis. So if we actually run this, we should see our 3D model in the center of our scene. Give it 1 second. So since I have another window with the Decentraland navigator open as I run this, it's taking a bit longer than usual. Just bear with me 1 second. There we go. So this is our scene. It's nothing terribly fancy, but it's a nice context to show the simple concepts that I want to show right now. So once our entity with components is created, we can also fetch one of these components from an entity. So we can do base.getComponent and fetch the transform component of our base entity. And I can do rotation / Euler angles equals new. So your Euler angles are the normal angles, the ones that have an x, y, and z coordinates. So they're the simpler ones to think. Like the engine by default uses quaternions, which are better for computing internally, but they're harder, for us to wrap our heads around. Quaternions have 4 values, which are from 0 to 1. So they're a bit harder to describe. So at least me, I always go for Euler. So for example, if I rotate this scene like this, oops. Now I just change the rotation of our entity. And yeah, that's all of these components have information that can be changed whenever we want, and by changing that information, we're changing how the things in our scene are rendered. So that's a very useful thing to know. Now, components can also be shared by several entities. So for example, we could create a cylinder shape component and assign that to multiple entities. And we could do wheel 1 So we're gonna add 2 different entities, and we'll assign the same cylinder shape to both of them. So wheel 1 dot add component cylinder, and wheel 2 dot cylinder. And right now they're sharing the same component. We actually also have to add both of these components, these entities, into the engine, because otherwise we won't be seeing them in the scene. And also we need to give these both a position in space, because otherwise they'll start in the 0, 0 space right here, which will be half out of bounds. Actually 3/4 out of bounds, pretty. So I'm actually gonna just copy this straight out from some notes I have so that we make it a bit faster. So the transform component has 3 different properties. It has a position, rotation, and scale. What did I mess up here? Something that shouldn't be there. It's fine to me. Did I mess up some bracket? Oh, yes, this one. No. Oh, I know, yeah. Need to close one more bracket, of course, yeah. Because there's the arguments for creating a new transform component, and then there's the add component function, which takes on the whole definition of the new component. Great. And for wheel 2, I'll also add this. So, these positions and details are quite specific, but I had checked these out earlier. So now we should have these 2 cylinder shapes appearing in 2 positions in the scene. There we go. And these both are sharing the same component for the shape. Now, one interesting thing we can do just as a test here is we can actually change the transform of one of these and have a completely different scale for one of the 2, and still that will be fine, because the information about the scale of the shape is completely separate from the information about the shape. As you can tell, right here we have one of these being deformed into a cone, and the other is just a disk, and that's all because I changed the scale of the y-axis, making it longer. So let's set it back to 0, 0, 5 so that it is a disk as well. And the same way we can also share a material component. So right now I'm gonna create a new material, and I'm gonna use this spirally texture we saw when we created the folder, and I'm gonna add that to both of them as well. So actually let's go my material. material. So you'll see that I can also share a same material component throughout several different entities. So a wheel texture, and we will point at file. I'm going to point at the file that we have in the images folder here. Great, and so now once we have our material created, we can assign it to our both entities. So wheel1 dot add component my material, and wheel2 dot add component my material. Great. So now we should see that these white disks should have this cool spiral texture on them. There we go. Awesome. Okay, cool. So far this is pretty simple. Let's just add one more component to each of our entities and add a click behavior. So you can use the onPointerDown component to have a function that is called every time that one of these entities is clicked. And for now, we'll just go. So the idea of the scene is that we want these wheels to spin whenever you click on them. And that, in order to do that, we're going to now dive into the world of systems, which is where this class starts getting more interesting. But yeah, for now, so far, this is pretty straightforward. We're just adding components to make our scene look a specific way, but it's all static. It's all just, you know, everything has a position, a shape, and a material in some cases, and it just stays there as it is. Now through systems is where we're gonna like breathe some life into what we have here. But I'm getting ahead of myself. Let's just create this here. So I'm gonna log a wheel every time we click on one of these wheels. And I'm just gonna add some more properties that relate to this onPointerDown component, so that first of all we only respond to actions from the pointer, so not other keys, and so that you can see a little notification when you point at it before clicking. Great. So let's copy the same for wheel 2. And right now nothing is going to happen. If I can see that there is a little notification there, and if I click on the wheel and I open the console, I'm going to see that there are messages getting logged. But of course the wheel is not spinning because I have to tell it how to do that and how to behave. So here we have this little wee thing popping up. Sorry, I clicked something I shouldn't. Here we go. We have this wee message, and we can see that it keeps appearing every time I click on our wheel. Great. So let's dive into the world of systems. So let's refer back to our little diagram here. Let's close this. So we have entities and components, and these are all pure information. They do not have their own behaviors built in. So entities, as I said, are just like places where we can gather different components, and they help give meaning to these components. They are context that allows these components to build something together with their, but they don't really do anything on their own. They just sit there. And systems, on the other hand, are the things that make things happen. They put things into motion. But entities and components don't know about the systems that are acting upon them. And likewise, systems, they don't store information about the entities and components. They just run functions on them. but the systems that aren't affected, they don't change over time. What changes over time is the information that is stored inside the components. We're gonna look at something a lot more concrete to make this, be a lot more graspable right now. But basically, like a same scene could have several systems, and these systems also don't need to know about each other. So a typical example could be a game where you have a system that controls the movement of an enemy, that the enemy is always going to walk towards the player. And then there's another system that controls gravity and how gravity affects this enemy. So you might have the enemy walking towards the player until it runs into a cliff and falls down. And so the gravity system is going to make the enemy fall down. But the system that tells the enemy to follow the player doesn't even know that happened. That system is still going to just keep walking towards the player. And the gravity system, it doesn't even know that, that the enemy is walking towards the player. It's just making things fall whenever they are in a cliff. And in this way, you can construct really interesting logical things from simple pieces. Part of the beauty of the entity component system is that you can put together simple behaviors and have something interesting emerge from these behaviors working together without necessarily them knowing about each other in any way. So let's build one system that is going to take care of rotating our wheels. Related to the course I did last week, we don't really need to add systems for a scene to behave in a certain way. We can rely on shortcuts. We can use the utils library, for example, which is a great resource, and it's very useful for simple use cases. For example, if we want to just rotate the wheel from one point to another, then we'd probably just use the rotate function in the utils library, and that will just take care of it. We don't need to think about adding systems. The component that comes in that utils library just handles creating systems in the background, and we don't need to think about that. However, that of course is simpler but has a lot of limitations. If we want to really be free to create whatever we want with these tools, then using systems is a bit more complex, but once you get the hang of it, it opens a lot of doors. So, without further ado, let's start building a system. So, actually we don't need to export because since we're working on a single file, let's directly define it as a class. So a system is basically an object that implements the iSystem schema, let's say. And this schema has a lot of predefined functions that the boilerplate functions that are meant to be overridden with specific and custom behavior that I built. And the most important one of these functions is the update function. Now, this function is going to be called 30 times per second, once for every frame in the scene. And whatever we code here is going to be executed 30 times per second. So in this case, we want wheel 1 to spin, right? So what we can do is, actually let's do this for neater by doing that transform and once we have this nice little neat pointer at our transform, we can do dot rotate. You can go with a rotate function, which takes, as you can see here, two parameters. One is the there we go. So one is the axis we want to rotate on, and the other is the angle, how much we want to rotate in this specific frame. Remember that we're going to be calling this function 30 times per second. So we actually want to make that rotation quite small, because it's gonna aggregate over time, right? So let's go with vector3 dot up. This is the direction in which we want to have this rotation happen, and for now let's just say 1. It's going to rotate 1 degree. Let's just test that and see what happens. Oh, of course, I'm missing one very important thing. So I created a system, but I never added the system to the engine. So I need one more line that goes engine dot add system rotator system. Oh, actually no, new rotator system. So what we have here is a class definition, but here I'm creating an instance of this. I could actually create several instances of the same system and add all of those, and that would aggregate the rotation that one of these does and have it spin even faster. I don't see why I do that, but it's a possibility. And so there we go. Our wheel is rotating on its own at a reasonably slow speed. Now, here's one thing to notice. This function, this update function, gets called 30 times per second in an ideal case. So the problem is that if everything runs smoothly, we will have 30 frames per second. But if the scene is handling many things, or if, for example, right now I'm also streaming video, which has a significant effect on my computer, you'll see that this movement isn't as smooth as it could be. And that's in great part because since some frames end up being skipped, we should be compensating for that in some way, because otherwise this function doesn't really get called 30 times per second. It gets called, let's say, 20 times per second, and at an uneven interval. Actually, we can see here that we're getting 9 frames per second, which is pretty bad, by the way. But it's not that this scene is particularly heavy, it's because I also have Decentraland open, because I'm in the world saying hi to people, and I also have the streaming of the video going on at the same time. So this means that this function isn't really being called 30 times per second. It's being called between 9 and 15 times per second, and as you can see, this number isn't even constant, and that leads to the movement being a bit jittery. So luckily, the update function has a default parameter, which is delta time, and delta time really tells me how long it's been since the last frame, and we can use that to our advantage. And so instead of doing 1, we can do 1 times dt, and now whenever we have a long frame, or a frame that comes after a long skip, this dt parameter will be larger, and if we multiply how much we're rotating by that number, well, we're gonna compensate for all of those bumps, and it's gonna be perceived as a lot smoother. So actually, since dt is really 1/30th of a second, to keep it at a similar speed as before, we'd have to do 30 times dt. So let's see how that goes. Okay, so here we are. It's not perfect because, of course, we have a very bad frame rate right now, but it is at least compensating for the stops we had before, and that also makes things be more consistent and more predictable, and it's definitely better than before. So right now we are just calling wheel 1 by name, and we're not really clicking on the wheel to spin it. If we want to actually have that behavior happen whenever we spin on it, one thing we could do is simply have a variable that, let's call it wheel 1 vel. Oh, sorry. Let's say this is equal to 0, And so instead of having 30 times dt, we can do wheel1 vel times dt. And whenever we click on wheel1, we can do wheel1 plus 20. Why not? So now the scene should start with the wheel not spinning, and the more we click on it, the faster it's gonna spin. That's the easy way. Now we're gonna go into something a bit more intricate. So great, there we go. Now the wheel is responding to our clicks. It's gonna spin faster every time because we're simply changing this value, which gets multiplied by the dt on every frame. Awesome. So right now we have just one wheel behaving. We have really two wheels in a scene, but how about, what if we had a scene with a lot of wheels? What if we had a template for a scene that we want to, have a changing number of wheels and arrange them however we want, and not have to think about changing the system every time we add another wheel? So a nice way to go about without having to think about all of that is to create a new component, a custom component, that's going to store this same variable here, but it's going to store it in a repository of information that is associated to an entity. So that's what we're going to do now. We're going to create a new component. And so we're actually giving this two names. That might be a bit confusing, but the real name that we're going to use is this second name. This first name is really just internal for the engine. We could call this whatever else we want, but this is the name of the component that we're going to assign to our entities now in a minute. So what information do we want to store in this wheel spin? But for one, of course, we're going to do speed, which is a number. But we could also have an active little flag thing, so that we aren't really concerned about rotating things that aren't active. And let's say that it starts false by default. And we can also give this a direction, so that it doesn't always spin in the same direction. We could have different wheels that spin in different ways. This is type vector 3, and we could give this a default value also, so that we don't have to think about providing values for this every time. Actually, let's also provide a default value for speed. Let's say it's 0 by default as well. So now we can add this component to our entities. So wheel spin is the name of our new component. Actually, we need to do new wheel spin, because again, this is just a class that we defined, but now we need to instance a specific instance for a wheel. And we could reuse this same instance on both wheels, but what would happen there is that if one of our wheels starts spinning, both of them would spin at the same time. As we want our wheels to behave independently, we're going to add a separate wheel spin component to each one. Great. So now, instead of just fetching the transform, so actually let's get rid of this so that we aren't using any of the old stuff. And we're gonna now also fetch the wheel spin component of our wheel. We're gonna start with just working with one wheel to slowly get to where we want to go. So we're going to fetch the wheel spin component of wheel 1 as well. And now, instead of going wheel vel, which was the variable we had created, we can do spin dot speed. Why isn't that working? Get component. Sorry, I need to fetch the component spin. Wheel spin, not add a new wheel spin. I was adding a new wheel spin component on every frame, which was crazy. Okay, great. And also, since our direction is now something that's stored inside the component, let's actually change this fixed value for also spin dot direction. And also let's do the following. Let's only do this if our wheel spin dot active is true, because otherwise we don't want to waste time doing calculations for wheels that aren't really spinning, right? So again, we're just working with one wheel now, and we'll now go into how we can actually work with any number of wheels that we want without adding extra code. But let's just confirm that this works as we expect. Oh, of course, we actually need to do something whenever we click on the wheel. We removed the old part, but we never added an equivalent. So let's do v1.getComponent wheel spin, and let's do active equals true, just in case it wasn't already active. And let's do speed is plus 20. Awesome. Okay, so now we should have our wheel rotating when we start clicking on it again. Okay, awesome, there we go. And the more we click on it, the faster it goes. We could even make this more interesting by, for example, having a bit of an inertia effect happen to a wheel. So from this same system, we could also be changing the information that's stored in the wheel spin component. So for example, after rotating our wheel, we could do spin.speed is equal to, let's say, so we're multiplying it times 99, so it's gonna slowly slow down. And since we don't want to, keep calculating the rotation of wheels when we're, below numbers that can't, really be shown by the engine, let's add a little flag that just sets the active flag to false in case it's going super slow. So let's do an if spin.speed is lower than 1, let's say, let's try with that value, then spin.active is gonna be false. Okay? So now we're gonna have some inertia when we spin our wheel, and we'll see that it slowly stops on its own. That feels kind of natural. I might want to tweak this a bit more to have a more realistic, curve, but it's sort of working as I expected, so that's pretty nice. Okay, so right now we're working with just one wheel. As I mentioned, it would be great to be able to have one single system that can handle as many wheels as we want, or as many wheels as are in the scene without needing to change any of this code. So a great tool to handle that is component groups. Component group is basically an array that fetches all of the entities that are in the scene that share a specific list of components. So in this case, we want to have a component group that knows about all of the entities that have a wheel spin component, so that we can act on each one of these wheels in our system. We don't want this list to include, the base entity that has, the 3D model for the scene. We don't want to spin that. That would be crazy. So we want to be able to, just iterate only over the entities that we care about and the entities that, would be affected by the system. So we're going to now create this component group. Oops. And the way you can create a component group is engine.getComponentGroup, and then you just list the components that you want inside the component group. In this case, it's just one, but we could have a list of components, and in that way, this component group would have only the entities that have the full list of components that I list. So I could have, wheel spin and transform, why not? I mean, this doesn't really change anything because all of my wheels also have a transform, but yeah, why not? Let's also add that to our list to make it more complete. And now this returns an array, and in our system, on every frame, we can, instead of just working on wheel 1, we can iterate over each one of the entities on this array. So for so we're going to take all of this chunk of code until here, I believe, right? And we're going to stick it inside this loop. And of course, we don't want to fetch stuff from wheel 1 anymore. We're going to fetch stuff from this wheel that is going to change as we go through the array. And now we should be able to have the same set of logic for every one of the wheels in the scene. Oh, important. I didn't actually add a behavior when we click on wheel 2. So let's just copy what I added here on wheel 1, because otherwise when I click on wheel 2, it's not going to respond. Not because the system is not working, but because I wasn't changing the components on it. And just to make it clear that things are different between the two wheels and they use different information, let's instead make this plus 50, and let's also change wheel 2 a little bit. Let's fetch wheel 2's wheel spin component, and let's change the direction so that instead of being the default vector 3 dot up, let's go with vector 3 dot down. So now this other wheel is going to spin on the opposite direction. Let's close this. Okay, so this is the final test. If we click on wheel 1, it's going to spin. And if I click on wheel 2, it's going to also spin in the opposite direction. So now our system is going over both wheels. Oh god, my frame rate is really bad. Sorry about that. But that's a consequence of having too many things running on the computer at the same time, including the streaming. So yeah, essentially this is what I wanted to cover on this tutorial. If you want to read more about entities and components and systems, the documentation has quite a lot of material on that. If you go to the section on architecture overview, you'll find documents about entities, components, and about systems that cover these a lot more in depth. There's going to be a lot more of these little webinars throughout this week, some of them given by me, some of them given by other people in the team, and some of them even given by people from the community that have built great things before. So I'm just gonna spin these wheels while I talk, so hopefully I'm gonna hypnotize you into getting psyched about going to these other webinars and about creating great content for Decentraland using the SDK. So yes, you will look at the other webinars that we'll be doing throughout this week, and you will create great content for Decentraland. Yeah, all of this scene was all a setup to be able to get to this, and discreetly be able to hypnotize you without you expecting it. Mwahaha. Alright, so yeah, this is all I wanted to show for this tutorial. I'm gonna stop recording now, but I'm gonna stick around here, and if you have any questions, I'll be happy to answer them.